Okay, so we heard actually in one slide of Tim's presentation that he compared the fan energy index with the energy efficiency index, and therefore it's really a nice follow-up here that we're having a presentation from Geoff Lockwood here about the energy efficiency index. Is it the right metric to regulate fan efficiency? And Geoff has actually worked at ebp-papst in this field for 32 years, and he's very active in the trade association and standard committees regarding fan energy efficiencies. He's involved in the British, European and international standard committees, and is chairing actually the fan working group of the European Ventilation Industry Association. So after having had the US perspective about the fan energy index, we have here rather the European opinion or view of energy efficiency index for fans. So let's hear from Geoff Lockwood about the Energy Efficiency Index.
Hello, I'm Geoff Lockwood, and I'm Chairman of the Fan Working Group of the European Ventilation Industry Association. This presentation discusses system efficiency from the perspective of the fan industry, looking at the problems and solutions to find a new metric. But first of all, let's look at today. Today we have an eco-design regulation in Europe that's very effective. It was published in 2011 and sets minimum energy efficiency requirements for fans between 125 watts and 500 kilowatts. It set a minimum limit in 2013 and 15, and that removed about 1/3 of the least efficient fans from the market. It stimulated innovation, and we estimate 46,800 gigawatt hours of energy has been saved between 2012 and 2017. So what's the problem? Well, there's pressure for change from a variety of stakeholders. First of all, the consultant acting on behalf of the European Commission during his review of the existing regulation was critical of us that we haven't developed the underlying metric of that regulation. And it's a fair criticism. Then we see in IEC standards, they ask the fan industry through ISO TC 117 to develop an energy efficiency metric. We don't think an energy efficiency index is appropriate. And then we have a request from the European Commission through a mandate for standardization. The first phase is complete, and a standard to support the regulation should be published shortly. The second phase asks for a system efficiency metric. The problem is we're not sure what that is. There's not a clear definition. We see it gets mixed up with the term extended product. We see there's a request for an energy efficiency index, and that talks about part load, and we can't find a definition of part load or partial load. What we do know is that the existing regulation is for a system. It's for a fan system. It looks at the electrical power input and the air power output, and the system consists of the driven equipment, impeller and stator, and of the drive, the electric motor, and the variable speed drive. Let's look at the term extended product. That is clearly defined as a driven equipment together with its connected motor system. A fan system is an extended product, and we call it a driven fan, and it consists of an impeller, a stator and a motor, and we're clear. IEC 119, I believe, confuses slightly the term system approach and extended product approach. Now, for me, it's clear a system approach within that standard. It describes a cascading effect from the product through to a larger product, through to the final system. And let's take the example of the fan. We have the fan system consisting of a stator, impeller and motor. And that can be used in a number of different other systems. For example, a condensing unit, which consists of a fan, a coil and a compressor. Or it could be used in a different system called a cooling unit, consisting of fans, coils and expansion valves. Those two systems can come together to yet another system, a refrigeration system, And so we have this cascade through from what I would see as a component through to the final system. And of course, that system goes into other systems, for example, the supermarket. What I don't understand is why the IEC standard says that the extended product, which is mixed up as a system, has to be an energy efficiency index. It doesn't fit for us, and I can't see it fitting for other systems through the cascade. Let's look at this energy efficiency index. It's defined in a pump standard, a European pump standard, as the average input power compared to reference power. And that average input power is defined as the weighted input over a load profile. So this sets an assumption that a system efficiency metric is an extended product approach that requires an EEI based on power input of a few operating points. And the standard states that the fan industry should develop one. Let's look at the example of one fan, a unique fan. It's got its own part number, it's published in a catalogue, and importantly, it's used by many different customers in many different applications. We, as a fan manufacturer, publish a graph. That graph, the blue line, is the performance at the full speed, sometimes called inherent speed. The grey area underneath indicates the optimum operating range for that fan. Now, one customer may use it at the fixed speed, full speed, and the duty point will modulate depending on how the load on their system varies. The volume and the pressure will change. Another customer may wish to use the speed control function and increase and decrease the rotational speed of the impeller to change the volume based on the system resistance. Another customer may wish to maintain a constant volume, and as the pressure in their system changes the speed of the impeller to maintain a constant volume. Alternatively, others use it to maintain a constant pressure, and as the pressure in the system changes, the fan speed changes to maintain that pressure with the consequence of changing volume. How can 4 duty points fully describe the full characteristic of this fan? Now let's look at a small fan, a small axial fan, right at the bottom of the range of the regulation, down over 125 watts, 150 watts. The orange line with the orange area describes a fan that's been on the market for a number of years. The blue line with the blue area is a new fan, brought out to replace the old one. It can fit in the same space envelope. It produces more volume flow, it produces higher pressure, and consumes less energy. It is more efficient, but more importantly, it has a much wider operating range. It can be used in a zone where the old fan can't. It is a much more flexible fan, providing bigger characteristic, better choice, better informed decisions. How can 4 operating points describe the increased pressure, the increased volume, the improved energy efficiency? So what is the solution? Well, first of all, we want to say that an energy efficiency index is inappropriate for us. We can see that we would be developing fans around those 4 points that, yes, we can tick the box and say they're energy efficient, but they're not of any benefit to our customers. We want to retain what works, retain the minimum energy efficiency limit based on peak efficiency, and remove the least efficient fans. We also want to point out that we should only use direct measurement in a regulation. That's a further discussion on another day. We wish to see revised definitions, and we are proposing revised definitions for extended product and extended product approach. We need definitions for part load and system efficiency metric, and we have proposed those definitions. The solution is product information for better informed decisions, and the good news is it's here already. What's missing is a standardized approach. Today, reputable manufacturers provide a lot of data about their products. The graph there shows the inherent speed and fan curves at a number of different reduced speeds. And the table shows the data at various points on those curves. And that data is not just efficiency. It states the power input, the current, the efficiency, and other impacts on the environment, the noise it produces. That data is collected into software programs, selection programs, where our customers can compare fans and look for the right one for their application. This is an example, and it's highlighting the best in class. Not surprisingly, the one at the top is the most efficient. It's the lowest power input, the best energy efficiency index, and the best specific fan power. But the fourth one down is the quietest. So do you want the least power, or do you want the lowest noise? Or perhaps you want a combination of the two. So this gives the user the ability to find the right thing for their application. So what we're saying as an industry is that we need a standardized approach to provide that product information. So for series produced fans that are not speed controlled, we need to publish the inherent speed and a number of data points. And that number of data points is described in our standard ISO 5801. Market surveillance can then take the fan off the market and check any one of those data points, or all of them. For a fan with an integral drive, or designed to be used with a variable speed drive, then we're proposing our data should be at least the inherent speed, the minimum recommended speed, and one speed in between the two. That way, our clients can interpolate between those fan curves and find the power input, the specific fan power, the fan energy index, the efficiency, whatever they wish, and the acoustic performance. Market surveillance can take this product off the market, and they can check our stated points on those curves to make sure we're not cheating. So it provides a method for market surveillance, and it provides information to make better informed decisions. There's some other things we need to do: industrial fans, jet fans, and circulating fans. We're working on them, but there'll be a similar approach. So in conclusion, keep what works. Regulation 327 is for a fan system. It's transformed the market, it's removed the least efficient fans, it's stimulating innovation, and most importantly, it's reduced energy consumption. There is a pressure for change, but it's confused. What is a system efficiency? What's part load? And there's a pressure to do something that's not right for the industry. Energy efficiency index is a backward step for fans. Let's keep what works. Let's keep a minimum energy efficiency limit based on peak efficiency and add to it better product information. Something we already do. What's missing is a standardized approach. And that's what EVIA is working on. We have published our problem statement. You'll find it on our website. And it gives far more information than I've just described today. We're just about to publish our proposal. And we're in discussions with the European Commission's policy officer suggesting how product information can be standardized. Thank you.
Thank you very much, Geoff Lockwood, and I hope to see your face. Yeah, works. Great. Do you hear me?
Yep, I hear you clearly. Thank you.
Perfect. Following actually your presentation, I was impressed by the detail of advantages you can get out of this software. You know, more noise, more efficiency, less efficiency. So that's a very good tool for choice. But I was wondering, are these softwares in any way certified, or is it just basically the producer which present their own products in this environment? And within this regard, we have a question actually from the audience, from Peter Ratkin, who's asking if such selection software would make sense if it would have products from many different manufacturers, which I think would be probably difficult, because then you would have to give away a lot of your internal technical data.
To answer your first question, in Europe, no, not at the moment, but as you heard from AMCA, they have a scheme where such programs could be certified. On a smaller scale, in some countries, I think I think it's RTL in Germany, they certify a scheme for fans in air handling units. So it's possible. My only concern, of course, is the scheme has to be on a standardized approach, so we all follow the same way. As for combining, that occurs already. There's companies out there that take our data and our competitors' data, combine them into packages and sell them as a package to certain sectors of the industry, where they can compare our fans and our competitors' fans. So everything's possible. As an industry, we just like a level playing field and a standardized approach. In our industry, we all have our selection programs, and we all have our algorithms to calculate the data between them. And to make sure that none of us are being clever, it would be good to standardize.
Now, I mean, it is obvious after these two presentations that we have quite a huge difference between the US approach, who's promoting the fan energy index, and the European approach for the European industry. So now, if I'm a globalist company, you know, I guess I would say Tilavek is actually selling in both continents. They would have to do both. They would have to actually create fan energy index as well as your approach with the peak efficiency and then the detailed data structure. Why is the push, or is there any push for actually some sort of consolidation in the future to be expected?
There is. I mean, there's a push for consolidation, but I wouldn't say there's, from an industry, it's not much work, because it's the same data. To calculate the efficiency, you want the electrical power input and you want the air power output. If you want to calculate the fan energy index, you need the same data. So, and other people want specific fan power. Some industries are much more interested in the specific fan power, which is a very good metrics in the building service sector, because it encourages you to reduce the pressure, and pressure is energy, just like the hydraulic discussion earlier. So it's not so much effort for us. The issue is politics. In Europe, we've got this metric since 2011, and it works really, really well. Mm-hmm. And why change? Why fix something that's not broken? And so we need to add to it. And to me, that's better informed, better information. That information could be in the form of energy efficiency index. It could be specific fan power. We're just saying it doesn't matter. It's about getting that data, and then regulators can use whatever metric they think is appropriate. Mm-hmm.
I mean, the energy savings based on the regulation 327, 211 is quite impressive, and I think the main goal has to be to continue on this path and further decrease the energy consumption. And yeah, as you said, and I completely agree with you, how it's done is actually not the most important thing.
Yeah, I think from a European point of view, the important thing is to continue what we're doing, and that's why I read the discussion yesterday about the timing of the regulation. For us, it's really disappointing that we reviewed the regulation in 2015, and 5 years on, we still haven't got it. And if you look at Klaus Handel's presentation yesterday, you see the industry's changed already. We've already changed our products to meet the new limits. Mm. The ones of us that are really concerned about it and really want and believe in it, but of course the ones that don't care, they're still on the old limits. So it's frustrating that what's easy, really, I think, we should implement the new regulation, and we should start working on the future steps forward.
Okay, thank you very much. There is somehow a question here. I don't know who actually asked it. Somebody is apparently confused. Is the FEA presented by Tim Matheson a while ago is the same as the EEI. I think that's exactly what we wanted to say. No, you don't have to confuse this. There's two different approaches with the same goal, energy efficiency. Just for a final word from your side to that.
The issue we have as an industry on EEI is that it constrains us to 4 points, and what we'd end up doing is perfecting our product on 4 points that are no use to anybody. The energy efficiency, the FEI, is about providing data right across the operating range, and therefore in that way we're quite similar. What we're saying in Europe, we want to show the data across the whole operating range, and the user then makes the right decision and gets the right data. The EEI just constrains us and gives us false information.
Okay, thank you very much for this explanation. I hope there's a clarification now,
if not, they can contact me.
Then we can see. Thank you very much.
Okay, thank you. Bye.